excuse me, from the bell work last week, number 7. Several of you had trouble with this problem. And folks, if you look, and this is the only time I think in the history of this class that I'm able to be a forest person. I can step back and say, okay, what would benefit me the most? Because my ultimate goal is to get a fraction equal to a fraction. That way I will have a proportion I can cross multiply and solve, okay? The way I can do that is by taking this whole thing and moving it to the left. And when I do that, now why am I taking this expression and moving it to the left? Pardon? It has an x on the bottom. They have like denominators. So look what I end up with. I get 9 over x minus x plus 4 over x equals 1/4. Okay? Now, you got to remember, when you have minus a binomial, you've got minus a quantity. And if you made a mistake, this, 85 to 90% chance this is where you made your mistake. 9, remember, you got to distribute that negative symbol. So it's 9 minus x minus 4 over x. And now let's combine like terms. 9 minus 4 is 5 minus x over x. And now I have a fraction equal to a fraction. And this is going to allow me to cross multiply. So x is equal to, or x times 1 is x. And then I've got 4 times this quantity. And now I'm going to distribute. That gives me x is equal to 20 minus 4x. Lots of you ask me about this. Something's not right. Well, just solve it and watch what happens. X plus 4x is 5x equals 20. Divide both sides by 5. And I get x is equal to 4. Okay? And then, of course, you got to go back and you got to plug it in and make sure that that's not an extraneous solution. Do you need me to check it? Okay, found your mistake? Okay. Any other questions on the bell work or the hot notebook? Okay. All right, let's put that away. Let's look at the homework from Friday. We were looking at page 143. On Friday, we got to finish up the series, okay? All right, same thing, folks. You know you're going to be given that formula. There's no reason for you to have to memorize that. But we are going to use, to find the sum of the geometric series, we're going to use S sub n equals a sub 1 times the quantity, 1 minus r to the n over 1 minus r. Okay? That's what we're going to be using to find the geometric series. Bless you. Bless you. Now, sometimes it's easy. And sometimes it doesn't warrant using this formula. If I were to give you a problem that said, find the sum of the geometric series to 6 terms, and this is what you're given. Why would you put that in a formula? This is so simple, folks. Don't use, if you want to use the formula on this, then use it to verify your answer. There's no reason. You know you're going to have 3 more terms. And obviously your ratio, 6 times what gets you to 18? 3. 18 times 3 is 54. 54 times 3 is what? 162? 162 times 3 is what? And then 486 times 3 is? Oh, okay, and we're done, right? No, why not? Because it told you to find the sum, okay? So you add them together. With your calculator. And what is that sum going to be? S sub n will be equal to? One more time. How many of you got 2184? Facile, right? Yeah. Yes, ma'am. Scroll up. Like, you need to see up here, or you need to see down at the bottom. Okay. How about that? It's very simple, folks. Read the instructions and think. Come on now, is this a common sense problem? This is total common sense. No formula. No formula here. And I'm a formula girl. But even I wouldn't do the formula on this. But I could. But I could. Let's look at another one. Changing gears. Everybody got that? All right, so let's change gears a bit. Look at the information you're given this time. How about a sub 1 equals 16, r is equal to 1/2, n is equal to 7. Now, if that's all the information you're given, and we're still finding the sum, now what are we going to do with that? You could totally plug it in. Could you go calculator on that too? Absolutely. Why? What are we given? We're given the first term is 16. You're given that your ratio is 1/2. And you have 7 terms. You could totally do this problem common sense. It's not going to, it's fine. It's going to take you a little extra work. If you plug into the formula, still finding the sum. You guys do that. Here we go. A sub 1 is what? Start plugging in values. 1/2 raised to the 7th power, right? 1 minus 1/2. Ugly. I know you don't like these fractions. What? Well, let's see. Because it ought to work out. 16 times. All right, now, so humongous number. 1/2 raised to the 7th power. Folks, you got to remember, when you have a fraction raised to a power, you're raising the numerator and the denominator to the power, okay? Over, what's 1 minus 1/2? 1/2, right? And I know y'all are flipping out because you're going, ugh, the fraction. All right, but just hang with me. 1 minus. Folks, all right, Lindsay, it's 1 over 128. You guys have your calculators, okay? Now, what's 128? And I'm going to show every step. You don't have to. You don't have to show the step. But folks, wouldn't I have, what? What's 128 minus 1? 127 over 128 divided by 1/2. You guys agree with that? Okay. Now, just for my own, because y'all know how I am about showing all my steps, I would have to put 16 over 1 times 127 over 128 over 100, or 1/2. Just for my own personal, I got to make sure all my steps are right because I'm kind of crazy that way. And then I would pray that I could cross cancel my 16 and my 128. Will 16 divide into 128 evenly? I don't know. Pardon me? 8 will go into both of them. 8 goes into 16 2 times. 8 goes into 128 16 times. All right, so that's going to give me, all right, I'm going to go down here. 2 times 127 is what? 254? $16 goes into 128 8 times? Oh, okay, I got you. All right. Why? Because I'm cross-canceling? Then put it in the calculator. Okay. 2 goes into 16. 2.
16 goes into 128 8 times. Yeah. 16 goes into 16. So 16.
Right? Is it right now? Okay, if you don't like the fractions, just put it in your calculator. 1 times 127, I know, is 127. Over 8 divided by 1/2. Folks, put it in your calculator. But be sure that you use parentheses for both of those. When you do, what do you get? 31.75? All right, now, 31.75, right? I know that I do not want an improper fraction that's going to be some god-awful numerator divided by whatever, okay? If you wanted to change that to a mixed number, whatever, I don't care either way. 31.75 is fine. 31 3/4 is fine. If you left it as an improper fraction, that would be fine. Did you go 7 terms? Add it up, let me see. Okay? Now look the way I'm turning this thing around. Okay? You're given the sum. You're given the ratio. You're given the number of terms. You got to find the first term. Plug it into the formula and work backwards, folks. Work with someone in front of you, beside you, behind you. But I want you to work this out yourself. You don't need me to guide you through solving an equation. It's an equation. Okay? See what you can do. If you go back and you check this at the end, if it's, oh, 1295 is not the fourth term. What's 1295? It's the sum of the 4 terms, okay? You got to get that in your brain. It's the sum. It's the sum of the 4 terms, okay? So here we go. Let's plug this stuff in here. 1295 is equal to a sub 1 times the quantity 1 minus 6 to the 4th power. Holy big number. 1 minus 6. All right, I can deal with that. And look, I have a number equal to a fraction. What do you know I'm going to do to 1295? I'm going to throw a 1 under it. And it's going to make me happy because it's balanced. Okay, here we go. I don't need to do anything with it now other than start simplifying things. 1 minus 6 to the 4th power. 6 to the 4th power is 1296. Over negative 5. You with me so far? To keep going. We get 1295 over 1 is equal to a sub 1 times negative 1295 divided by negative 5. Happy. I'm okay with that. Now, at this point, you could look at it and go, all right, I can do one of two things. I can cross multiply and solve, because it is a proportion. Or, folks, can I do this and be a big girl and say, you know what? What's negative 1295 divided by negative 5? Positive 200 and who? So now I've got 1295 is equal to 259 a sub 1. You guys see that? And now how am I going to solve for a sub 1? Divide by 259. I mean, it's 6 in one hand, half dozen in the other. It's not a big deal. But I get a sub 1 is equal to 5. Now, how many terms does this thing have? 4 terms. Check it. Just check it with your calculator. 5, boom, boom, boom. What was the ratio? 6? All right, so come on now. 5 times 6 is 30. 30 times 6 is, yep. 180 times 6 is 1080. Well, I don't have the right number. What shall I do? Add them together. And when you do, that's when you get 1295. So I know I'm right. Now, did that take me long? No. It's not going to take you long on an SOL test. It'll take you an extra minute at most. You guys don't rush through this. And you're going to take it in first block. Okay? So you're good. Take all day. I don't care. I don't want you stressing yourself out about it, because it's not necessary. This is small potatoes in the grand scheme of things, folks. So small potatoes. Okay? Questions on this? Facile, difficile. Facile, it's just a formula. Okay? Can we move on? We're going to move on. All right, we're going to pick up some notes from the next section. Which is section 11.4. I'm not going to get through all this today because I want you to have time in class to do work on homework. But infinite geometric series. Infinite, yep, geometric series. We're going to be looking at 2 types of series of numbers. Infinite means what? Infinity means forever, okay? No end. That symbol. It's a sideways 8, but you can do this. I have a difficult time making them look good. You can do it like that right there. A sideways snowman. Snowman, because we want snow. All right. But infinity. Here we go. 2 types of series, folks. There's a convergent series and a divergent. Because, folks, when we're talking about infinity, we are talking about, you know, something that may not have an end. What do those 2 words mean? Converge. Converge means to come together, right? And, well, y'all know how I am about pictures. Is that coming together? Converging? It's converging upon one value. Okay? Let's see how I did this. Coming together, coming to an end. Divergent, how would I represent that with my little drawings? They're going to go from a point out, right? you think a divergent series is going to have any end to it? It's going to get bigger, 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 right? All right, so here's what you need to remember. Convergent series that's just to kind of get our, just to whet your appetite a little bit about what it is. A convergent series, the sum approaches a finite value. It has a definite end, okay? The ratio, when you take the absolute value of R, it's going to be less than 1. The divergent series, the sum does not approach a finite value. It's not getting closer and closer and closer and closer and closer and closer to a value. It's getting farther and farther away. All right, now look at the convergent series. If the ratio is less than 1 in a convergent series, it's getting smaller. Then what do you think the ratio is going to do in a divergent series? It's going to get bigger. How do you think we're going to represent that? Greater than or equal to 1. You'll see how all this works here in just a second. And I have to be honest. This is new to me too. So we're in this section together. All right, so what's all that mean? What we have to be able to do is we've got to be able to look at a list of numbers, and we have to be able to determine, first of all, is it arithmetic sequence, is it geometric sequence? We know how to do that. And then we can split it down into another little section of, all right, so if it's geometric, now is it a divergent series or a convergent? Okay? We'll see how that's going to work. It only goes with geometric. Only goes with geometric. All right, so let's see how this is going to work. I want you to determine whether the infinite geometric series is convergent or divergent. You got anybody so you can write that down. All right, you ready? Well, watch, okay? Let's look at this list of numbers because we're talking about a series, so we're talking about the sum of the list of numbers, all right? Okay, check this one out. 729 plus 243 plus 81 plus ... Think about it visually. Do that again with your hands. You went, no, what did you do to begin with? You went this to this. Did y'all see? Ted went big to little. Do you guys agree with that? Big to little. So it must be what? Convergent. Now, I looked at it when I was studying these notes, and I went, well, yeah, it's big numbers to little numbers. They're getting smaller and smaller and smaller. But why would the notes give me that ratio, that absolute value thing? So let's check it. Let's check it and verify what we're thinking. We're thinking, do you guys agree that it looks like it's a convergent series? Yes? Okay, pardon? Because it's starting with a big number and getting smaller. Okay? And to me, that's what that word means, because you are converging on something. Okay? Here we go. Time out. 243, don't make fun of your teacher. Divided by, it's up here, psst, not out the window, psst. 243 divided by 729, what is it? It's 3. All right. Ratio is 1/3, and she did say AI. Okay. All right, now. 1/3. Holy moly. What's the absolute value of 1/3? Distractibility over there. Psst. Okay. Is that true? Is 1/3 less than 1? Yes. So did we just verify that this is a convergent series? Yes, hallelujah. Okay. One more example. One more example. Questions. But is this something you have to memorize? Yes, you have to know that R is less than 1. R is greater than or equal to 1. But it's kind of connected. Psst, pay attention. Last example. Last example for the day. Here we go. Determine whether this infinite geometric series is convergent or divergent. 2 plus 5 plus 12.5 plus ... Now, don't just assume, since you got a convergent the first time, that this is automatically going to be divergent, okay? Don't assume it, prove it. Explain why, justify. Now you feel like you're back in geometry. But you have to prove it. 12.5. Yes, you do, too. No, it is not out the window, so don't stop looking. Stop it. Good job. Here we go. 2 plus 5 plus 12.5. Folks, what's it physically look? Up here. What's it looking like? It's going this way. It's going this way, isn't it? Which is divergent. Okay? Now, because it's the little number going to big, it's little getting bigger. Okay? That's all I look at. And now I'm going to verify it. Okay? And I'm going to tell you, I have to see this picture to be able to determine which word. You guys are so distractible. ADD, all of you. I love you anyway. I know I do. All right, here we go. Absolute value. First of all, we got to find the ratio. Which is what? 2.5. So now we're going to take the ratio. This one should be greater than or equal to 1. Right on. 2.5. What's the absolute value? Is the absolute value of 2.5 greater than or equal to 1? Yes, which we just proved that it is indeed divergent, okay?
I just don't understand why the definitions.
When we find the sum, you will see this will. Hey guys, listen. This is all. I'm giving you just enough to be able to determine, if I gave you a list of numbers, to look at it and go, hey, it's convergent, hey, it's divergent. That's all I'm giving you today. Now, the fact that you're going to end up with a finite value, it's going to approach a finite value or not approach a finite value, that will become more clear to you tomorrow, because we're not done with this section yet. I've got to finish it out, then we'll review, and folks, we will test on Wednesday on all these formulas and things, okay? If we're not here tomorrow, then everything will be pushed back a day. If we're not here 2 days, then we will figure it all out when we get here. Or you could always check out, I mean, I'll put stuff out there so you'll know on Facebook, because you guys would care about that. Here we go. Here's what I want you to do. It will all become more clear once we work with that formula, okay? I want you to, right.
It's all about finding the sum and converting the diverse.
No, nuh-uh. Not even, we're not even there. This is all finishing up geometric. We're going to finish up the infinite tomorrow in class. Okay? Geometric sequence, not what, everything from Friday and today. Friday and today. Okay? Friday and today.